Hi everyone, it's me, EJ, and today we will talk about distributive property in algebra. I will elaborate how distributive works in algebra and how can we apply in real life situations. But before that, let's explain the word distribute. It means to give something to each member of a group. Let's say there's a politician. Not this one. A politician who gives flyers with their platform to each place on their subordinates. Another example here is Santa Claus, who gives so many gifts in every place he had. Oh, do you think Santa Claus really exists? Okay, that's not our topic. My point here is we give something, anything to each member in a particular group. That's how we use distribute. In using distributive property, you should know the order of operations. This is actually the way of allowing us to change the order of operations we do in a certain types of problems. For example, we will not include algebraic expressions yet since I will show how distributive work. We have 10 times the group 16 plus 11. I will going to simplify this expression in a two different way. How? In my first solution, I will use the basic order of operation rules. And for my second solutions, I will use distributive. So for the first way, our order of operation rules tell us that we need to do any operations inside the group first. And since these parentheses form a group, we first need to add the 16 and 11, which gives us 27. Next, we can multiply that by 10, which gives us a final answer of 270. Now let's use the distributive property. This allows us to change expression into different form. Instead of multiplying the 10 after we add the 16 and 11, we can distribute the factor of 10 and multiply it by each member of the group individually. That means we will make a copy of the 10 times for each number of the group, the 16 and 11. So after applying the distributive property, our expression looks like this: 10 times 16 plus 10 times 11. Because we distributed the multiplication to each member of the group isn't needed anymore, so the parentheses can go away. Now we can continue to simplify this new form using our order of operation rules. Those rules tell us to do multiplication before addition. So 10 times 16 is 160 and 10 times 11 is 110. The last step is to add those two results together. 160 plus 110 equals 270. Wow! Look at that! We got the same answer in both cases, which means our original expressions are equivalent, even though they have different forms. So the distributive property is basically a way of getting rid of a group that is being multiplied by a factor. If you distribute the factor to each member of the group, you will get the same answer you would if you calculate what's in the group first and then multiply. This is how we distribute in arithmetic. But in algebra, things are a little complicated because we are not just working with known numbers. Algebra involves unknown values and variables, right? So in algebra, you might have an expression like this: 10 times the group x plus 11. In this expression, we don't know what value of x it is. It could be 16 like in the last expression, but it doesn't have to be. Why? Because it could be any number at all. And since we don't know what it is, that means we can't simplify the group first in this case. Our only option here is to either leave the expression just like this and not simplify at all, or to use the distributive property to eliminate this group. Just like what we do in arithmetic, we can distribute a copy of the 10 times to each member of the group So the group goes away and we end up with 10 times x plus 10 times 11. The 10 times x can't be simplified any further because we still don't know what x is. But we can simplify 10 times 11 and just write 110. So the distributive form of this expression is 10x plus 110. And even though we can simplify these expressions all the way down to a single numeric answer without knowing the value of x, we do know that these two forms of the expressions are equivalent because they follow the distributive property. So the distributive property works exactly the same way whether you're working with numbers or variables. In fact, in algebra, you will often see the distributive property shown like this: x times the group y plus z equals xy plus xz. Or you might see it with different letters like A, B, and C, but the pattern will be the same. This pattern just telling you that these two forms are equivalent. In the first form, the factor x is being multiplied by the entire group. But in the second form, the factor x has been distributed, so it's being multiplied by each member of the group individually. And if you're just thinking, what multiplication? Remember that multiplication is the default operation, which is why we don't have to show it in this pattern. Since x is the right next to the group, it means it is being multiplied by the group. And on the other side, since the copies of the x are the right next to the y and z, it means they are being multiplied also. And even though this pattern is usually shown with addition in the group, remember that it also works for subtraction, since subtraction is the same as negative addition. The distributive property does not apply to the group members that are being multiplied or divided. This is the basic pattern of the distributive property. It's usually just shown with two members in the group, but remember that it works for groups of any size. We could have A times the group B plus C plus D, and the equivalent distributed form will be AB plus AC plus AD. I have another examples here with a combination of numbers and variables that might help you to see the patterns of the distributive property. 8 times the group C plus D plus E can be changed into the distributed form of 8C plus 8D plus 8E. 16 times the group X plus Y plus 2 can be changed into the distributed form of 16x plus 16y plus 16 times 2, which is 32. And B times the group A minus C plus 5 can be changed into the distributed form of BA minus BC plus B5, or pi b, which is more proper. Whether you are dealing with numbers or variables or both, the key concept is that the factor outside the group gets distributed to each term in the group. Speaking of each term of the group, we also know that terms were part of polynomials, realizing that these groups of things being added or subtracted are really just polynomials. I will help you see why distributive property is so useful in algebra. What if the polynomial was just a little bit more complicated? Like this: 5 times the group 2x plus 3y. In this expression, each of the terms in the polynomials does have a number part that is being multiplied by the variable part. But we can still use the distributive property to distribute a copy of the factor 5 to each term in a polynomial. But notice that even though the terms do have multiplication in them, the terms themselves are being added. So we distributed a copy of the factor 5 to each whole term, but not to each part of a terms. In other words, We treat each term in a polynomial as an individual member of the group. Even that term has multiplication going on inside of it, which is common since there is often a variable part and number part being multiplied together. And that's all. Again, this is EJ. See you on my another episode. This is Mathematics.